Hello, in this session we'll see first problem based on fitting of a parabola. So it says calculate fitting of a second degree parabola using the given data. So the data given is as such xy 0, 1, 2, 3 and 4 with the values 1, 1.8, 1.3, 2.5 and 6.3. Now, forming a second degree parabola equation for the given data, we can first see the number of data provided is 5. So in that case, n will be equal to 5 here. Now, with this, the equation required, let's say, is y equal to a naught plus a1x plus a2x square. Then the normal equations for this will be summation a naught n plus a1 summation x plus a2 summation x square equal to summation of y, a naught summation of x plus a1 summation of x square plus a2 summation of x cube equal to summation of xy, and a naught summation of x square plus a1 summation of x cube plus a2 summation of x to the power of 4 equal to summation of x square y. So these are the three equations which will help us to find the unknowns a0, a1 and a2, and then we can find the second order parabolic fitting equation for the given data. But for that we require some of the variables value, that is summation of x square, summation of y, summation of xy, summation of x square y, and so on. So with that, we'll try to form a table which will contain all the values. That will be, so forming a table which contains x, y, x square, x cube, x to the power of 4, xy, and the last one which is x square y. With the data given, that is 0, 1, 2, 3 and 4, and the y value given as 1, 1.8, 1.3, 2.5 and 6.3, the xr value will be 0, 1, 4, 9 and 16. The x cube value will be 0, 1, 8, 27 and 64. X to the power of 4 will be 0, 1, 16, 81 and 256. The xi will be 0, 1.8, 2.6, 7.5 and the last one which is 25.2. X square y will be 0, 1.8, 5.2, 22.5 and 100.8. Now with this, we'll also try to find the summation of all such values, and we'll get the total as summation of x, which will be 10, summation of y, which will be 12.9, summation of x square will be 30, summation of x cube will be 100, for x to the power of 4 it will be 354, 37.1 and 130.3. Now with all the required values found here, we can move into the equations and we can fit in the values so that we can try to find the unknowns. So Substituting these values in normal equation, we get, since n is 5 here, starting with that, the first equation will become 5 times of a naught plus 10 times of a1 plus 30 times of a2 equal to 12.9. Comparing it with the first normal equation is a times of n plus a1 times of summation x plus a2 times of summation x square plus summation y. Comparing it with the first equation, this is a naught times of n plus a1 times of summation x plus a2 times of summation x square equal to summation y. So putting all these values, we'll get the first equation. The second equation will be 10 times of a naught plus 30 times of a1 plus 100 times of a2 equal to 37.1. And this is coming from the equation a naught times of summation of x, a1 times of summation of x square plus a2 times of summation of x cube equal to summation of xy. So this is our second equation. Now the third equation will be 30 times of a naught plus 100 times of a1 plus 354 times of a2 equal to 130.3, and this is the third equation, which we'll get from the equation of a naught times of summation of x square plus a1 times of summation of x cube plus a2 times of summation of x to the power 4 equal to summation of x square times of y. Now these are the set of simultaneous equations which we have. Solving this with any of the linear methods, we can find the value of a naught, a1 and a2. In that case, forming the matrix, which will be 5, 10, 30, 10, 30, 100, 30, 100, 354, and the variables a naught, a1, a2 equal to 12.9, 37.1 and 130.3. So with this equation of the form ax equal to b, we'll be using Cramer's rule to find all the unknowns. So let us start with finding the del, which will be determinant of 5, 10, 30, 10, 30, 100, 30, 100 and 354. This comes out to be 700. The del 1, which will be equal to determinant of 12.9, 37.1, 130.3, 10, 30, 100, 30, 100 and 354. This is obtained by replacing the column 1 with the constants, and that will give the determinant to be 994. Now going for delta 2 and delta 3, delta 2 will be 5, 10, 30, 12.9, 37.1, 130.3 and 30, 100 and 354. This is obtained by replacing the column 1. This is obtained by replacing the column 2 with the constants, and this value will be negative of 749. Now the third one, which is delta 3, will be equal to 5, 10, 12.9, 10, 30, 37.1, 30, 100 and 130.3. This is equal to 385. So we have found all the values, that is del, del 1, del 2 and del 3. With this we can check that the value of A naught will be equal to del 1 over del, A1 will be del 2 over del and A2 will be del 3 over del. So A naught is del 1 over del, A1 is del 2 over del, A2 is del 3 over del, and these values will be 994 over 700, negative 749 over 700 and 385 over 700, which will be equal to A naught equal to 1.42, A1 equal to negative of 1.07 and A2 equal to 0.55. So the equation of the parabola for the given data becomes y equal to 1.42 plus negative of 1.07 times of x plus 0.55 times of x square. So this is the equation we were looking from the given data, and we have found this with the help of the method of least square method. Thank you.